Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azmi bin Abdul Aziz, and I'm gonna give a little bit explanation for our assignment, which is mathematical model and simulation of a DC motor. This assignment aims for students to be able to familiarize with some basic features in MATLAB Simuli and able to simulate of a DC motor drive. Students also need to be able to analyze and observe the motor steady state and dynamic performance by varying the motor input parameters such as armature voltage. That is a little bit explanation for our assignment. We can continue to another part.
Assalamualaikum, my name is Norma Zimiti Baharin and I'm gonna show the simulation and the model. Alright, so here we got all the values that we already wrote, and all the values has transferred into this workspace, so we can run. Okay, and then I already create the model 1, which is mathematical model to calculate the armature current, and model 2 is mathematical model to calculate the field current, and the last one is model 3, which is mathematical model to calculate the rotor speed. I already checked all the connection and make sure the connection is correct, so we can run. Alright, so we have to take a look for this scope in model 1. So this is the Simulink, the result. The first one is armature voltage, and the second one is armature current. So yep. And for the second model, the first one at the top is field voltage, and the second one is field current. And for this third model, we have from the top is electromagnetic torque, TE, and the second one is load torque, TL, and the last one is rotor speed. As we can see, at the load torque, we got 0 value. It is because as we look at the TL here, we set it at 0. But if we increase it to 2 at 4 seconds, so let's see. Okay, see, the load torque is changed. Yep, follow from 0 until 2 at 4 seconds. So that's all. Thank you.
Now we move to the mathematical equation. So we have voltage equation at armature winding. So we need to calculate the IF, and we get IF equal to 1 ampere, and we calculate the IA using this formula, and we get IA in omega. So we need to calculate the omega first, and we get omega this value. After we get the omega, we can calculate the IA, and we get this value for IA. After that, we calculate the electromagnetic torque, so we get 2.43 Newton meter. After that, we move to second part, which is voltage equation at field winding. We need to calculate the IA, and we get IA in omega. So we need to calculate the omega using this formula, and we get this value of omega. After we get the value of omega, we also can calculate the IA, and then we can calculate the TE equal to 2.43 Newton meter. Lastly, we have torque equation. So we have this equation. VA we use 120 because question need we to decrease from 240 to 120. So we use this value for VA and we get omega 66.07 radian per second. After we get the omega, we put the omega in equation of IA that we calculate before, and we get IA equal to 1.79 ampere. Lastly, we calculate the electromagnetic torque equal to B omega, and we get electromagnetic torque equal to 1.21 Newton meter. So that's all from me. Thank you.